Welcome to a new lesson. In this video, I will work on another problem, this time on a problem from netcode, and it is about number of connected components in an undirected graph. So the question is that there is an undirected graph with n nodes. There is also an edge an edge array where edge I equals AB means that there is an edge between node A and node B in the graph. The nodes are numbers from 0 to n minus 1. Return the number of connected components in the graph. It is the main question, that we should return the number of connected components in the graph. For example, here n is 3, that means there are 3 nodes, that should be numbered from 0 up until 2, 0, 1, 2, because it says from 0 up to n minus 1. And the output is 1. Why is 1? Because these edges show that, first of all, you know that there are 3 nodes, and it shows that between node A and node 1 there is a connection, and between node 0 and node 2 there is a connection. For example, if I say it is node 0, it is node 0 and it has a connection to node 1 like this, and also node 0 has a connection to node 2. Let's say it is node 2. So you can see that node 0 has a connection to node 2 also. So for that reason it is a 1 connected graph and the output should be 1. But in this example, n equals 6, that means there should be 6 nodes, and this edges shows the connection between them. It shows that node 1 and 0 has a connection. Let's say it is node 0, it is node 1, and these two have connection with one another. Node 1 and node 2 has a connection. Let's say it is node 2, and node 1 and node 2 has a connection. Node 3 and node 2 has a connection as well. Let's say it is node 3. Node 2 and node 3 has a connection. And node 4 and node 5 has a connection. Let's say it is node 4 and it is node 5. These two have a connection to one another. So here you can see that there we have 2 connected graphs. For that reason the output should be 2. So now that we know that what the question is asking about, and you know that how to traverse a graph from previous lessons, now the point is that when you traverse this graph, you should consider how many connected components are there. And how can you recognize that? You know that when you start traversing a graph using breadth first search or depth first search, that works only with one connected graph. That means those nodes which has connection to one another. So when you start checking these nodes from here up until last one, you see that when you start visiting from here to there, it ends, and the traverse again starts from here. So that means there are 2 separate connected graphs. So now let's write a solution. How can we traverse these graphs, and how can we count the number of connected components? Okay. First of all, you should know how to represent a graph in coding. You already know that. And we can represent a graph in two ways in programming. One is its adjacency list, and the other one is adjacency matrix. Right now, let's uh, represent this graph using an adjacency list, and then we can traverse this graph from first up until the last nodes and count the number of connected graphs. So when you say that you want to represent a graph using an adjacency list, that means you create an object, and you know that the object is a key value data structure. The key should be your nodes, and the value should be the list of nodes which that key node has a connection to them, like this. Constant adjacency list equals like this. And when you create this list, so all the nodes should be the key, and its value should be the list of nodes that this key node has connection to them, like this, up until the last one, like this. So now you know that you are not solving this problem only for this example. That means we should write a dynamic object, because right now if we write this example for this, even it cannot pass this test case, because here the nodes are 3. So for that reason, we should not create the element of this object manually. We should create this dynamically based on the number of nodes that we receive here. So we should check that. So now let's first create n number of elements for this object, and obviously for that you need to create a loop for this. So let's create a loop for let I equal, it starts from 0, the number of nodes, up until the n. I is less than n and I plus plus. So every time you create adjacency list, the I equals to an empty array. So here you are creating an empty here you are creating an object that has keys, but the values are empty arrays, because the values come from these edges. So that means now we have to go through this edges array and get the nodes, and also specify the connection between these nodes, and we have to add all those nodes which are connected to the key node. So first let's traverse or iterate through this array for let, and you know that every element in this array is an array also, and both of them shows node. So for that reason we can directly spread them into two variables, let's say a and b of ages. Now if we extract this one, for example, from these ages, and we put the first node in A and the second node in B, so now we can say that if these two exists, that means it is a neighbor to this one, and this one is a neighbor to this one. So now let's add this in this neighbor list. So we should get this adjacency list, A. So when you get adjacency list A, you get an empty array now at first. So when you get this array, either there is empty or some already nodes added, you get that array, and then you add the new node into that array. So you can say adjacency list A dot push B. So if we said if 0 has a connection to 1, then that means 1 also has a connection to 0, like this. 0 has connection to 1 and 1 has connection to 0. So we make it the for B as well, adjacency list B dot push A. So this way you create your object and you add all the neighboring nodes to the key node. So now that we have our graph here, which represented in this adjacency list, we can traverse this graph and we can recognize the number of connected components. So for that reason, let's start traversing this graph. And for that, we have to create a loop that should go through each node in the element in this graph. That means if we have n number of nodes, that means we should repeat n number of loops. So let's create a loop here for let I equals 0, and it continues until it is less than n I plus plus. So now, in order to keep track of visited nodes, let's create a set, and there we have to add our visited node. So const visited equals new set, and when we start checking the nodes, first we check if it is already added in the visited or not. If it is not visited, we have to visit, otherwise we don't need to visit that. If it is visited, that means you have already checked that. But if it is not visited, then that is when we need to visit that. So let's suppose it is the first loop, a 0, and we have a node of 0. Is it added in the visited list? No, it is the first one. So that means a component begins. So let's have let the component, it should be acting as a counter. Now it is 0, but here as soon as you found a node which is not visited, so that means it is the beginning of a new connected graph, a separate component. So you say component plus plus, and then if this node is not visited yet, so you increase the number of components. However, now you have to start visiting all its connected nodes up until number 3, for example, in this example. Because when you come to the number 4, it has to check if it is visited or not, no, and then the component has to increase by 1. So let's create a function for either breadth first search or depth first search to visit all its nodes which are connected to one another. And for these connected nodes, we should not increase the component. So now let's create a separate function and pass this node that we are checking here, BFS. So I'm creating that here, const BFS equals, it receives the node. Okay, So with the BFS, the first thing that we need is to have a queue in order to keep track of the nodes. So let's create a queue, const queue equals add the starting node to that queue. So now you have a visited list here. Let's put it above queue so that we can use that in this queue also. So now that we received this node and put in the queue, so we add this to the visited list also. Visited dot add this node. Okay, so now we keep processing our queue, and we say that while queue is not empty, while queue is greater than 0, we have to keep processing, and by that we mean extracting the first inserted node. Let current equal queue dot shift. So for example, here we are processing the first node, and we removed that from the queue that we had inserted. So now here we add its neighbor also to the queue. So how can we get its neighbors? So we have already them here as a list, and we just all its neighbor are an array, and we have to iterate through that loops through that array, and add all the neighbors into the queue. So now let's say for let neighbor of adjacency list current adjacency list current So when you are adding the neighbor, before adding them to the queue, we check them. Are they already visited or not? If they are already visited, so we should not add them to the queue because we can avoid extra process this way. So first let's check if it is not visited, then add. Otherwise, do not add this. So say if it is not visited, visited dot has a neighbor. If neighbor is not visited, add this to the visited list and to the queue. Visited dot add a neighbor, also add it to the queue. Queue dot push a neighbor. Okay, there's it. So it keep continuing until it reaches the last one. For example, from 0 up until 3. When it is processed, so the BFS finishes, and then our loop continues. This time, when it comes here and checks, for example, number I, it says that it is already visited. If it was not visited, you would add the component, but it says it's already visited. Then you move ahead. You come to number 2. Then it's already also visited. Then you come to number 3. It's also in the visited list. And finally you come to number 4. So when you come to number 4, it says that it is not added in the visited list. So if it is not added in the visited list, that means it is the beginning of a separate component, separate part of the graph. So you increase the number of components and then call the breadth first search method on this node as well. So you say that, well, pass this node as a starting point and visit all the uh, other components which are connected to one another. That it comes here and it keeps visiting all the neighbors up until the last one. So this loop continues until it is less than n, and finally we can get the number of components. Okay, finally here return component. Let's run this. Yeah, accepted. Case 1 and case 2, both of them are accepted. So I hope you understood this. It is quite easy. Here the whole point is actually creating this list. When you could create this list, then you already know how to work with breadth first search, and now you know how to create a dynamic object. By dynamic I mean like create an object that has the key and value pair to a number of given number. So until the next problem that I come to solve for you, have a nice time everyone. However, if you have any questions regarding this problem, add them in the comment. I will go through them and answer your questions in the next video.